Welcome back. Continuing Module 2, Topic 3, Lesson 2, Activity 4, and we're on page 324. Using unit rates to make comparisons. Habits of mind, we're going to attend to precision, so making sure we are precise and exact. The local paper published these rates on gas mileage for a few new cars. The Avalar can travel 480 miles on 10 gallons of gas. The Centaur 400 on 8 gallons. The Comstar can travel 360 miles on 9 gallons. Change each rate to a unit rate so that it reports miles per 1 gallon of gas. And remember, unit rate means per one. Per one. Okay, so question 1. Change each rate to a unit rate so that it reports miles per 1 gallon of gas. The Avalar, 480 miles. Remember MI for 10 gallons of gas. Okay, so if we divide that out, it's a division by 10, so we know it's 48 miles per 1 gallon. We divide that by 10. 400 miles on 8 gallons for this Centaur. So if we do 400 divided by 8, well, 40 divided by 8 is 5, so this will be 50 miles per 1 gallon. And then we have the Comstar, which is 360 miles for 9 gallons of gas for every 9 gallons. 36 divided by 9 is 4, so 360 divided by 9 is 40 miles per 1 gallon. So how did you calculate each unit rate? We divided miles by gallons. How can unit rates help you to compare these cars? So if unit rates allow me to compare using the same amounts. So, like, we can't really compare a 10-gallon rate to an 8-gallon. A car that we're getting 480 miles for every 10 gallons is hard to compare when we're looking at something that uses 8 gallons or something that uses 9 gallons. So using unit rates allows me to compare the same amounts. So in this case, it was the per 1 gallon. So which car is better? Do you want the car with the lowest unit rate, like the bags of popcorn? So do we want the one that gets 40 miles per gallon? Or do we want the one that gets 48 miles per gallon or 50 miles per gallon? So in this case, we want the bigger one. So we're going to say no. You want the most miles. Oh my gosh, it's too hard to write here, and I have glare from the light. Most miles per gallon possible. Okay, right? Because you want to be able to drive as far as you can on the same gallon of gas, right? Okay. Guests at a dinner party. It says take note, make a prediction before you begin calculating, and then use ratio reasoning to answer each question. Guests at a dinner party sit at 3 tables. Each table receives large round loaves of bread instead of individual rolls. Each person at the table shares the loaves equally. Table 1 has 6 guests and is served 2 loaves of bread. Table 2 has 8 guests and has 3 loaves. Table 3 has 10 guests and is served 4 loaves of bread. So we have 2, 3, and 4. Predict at which table the guests will get the largest serving of bread. Please pause, make a prediction. Okay, so in past years, I've had kids predict table 1 and kids predict table 3. Okay, and on the next page, it says determine how much bread each guest at the table will receive. Okay, so let's get those numbers transferred over here. So table 1 was 6 guests, 2 loaves. So there was 6 guests, 2 loaves. So before we go any further, let's figure out, are we going to do loaves per guest or guests per loaf? I want you to pause for a moment and think about that and talk with your table partner and tell me which one you would use. Okay, so hopefully after your discussion, you came back and thought that we want to know how much bread each guest receives. So the question's kind of giving us the order. So bread for each guest. So we want the loaves per guest. We want the guest to go down to a unit rate of 1 per 1 guest. If we did it the other way, we would have the number of guests per loaf, and then we would have maybe a fraction or a decimal part of a guest for each 1 loaf. So that doesn't make sense to do. So loaves per guest is the way that we'll set this up. So in table 1, so we have 2 loaves for every 6 guests. And when you divide that, that reduces to 1/3. So 1/3 of a loaf per guest, and that in a decimal value is 0.33. Okay, let's look at table 2. Table 2 was 8 guests served 3 loaves. 8 guests, 3 loaves. So 3 is going in the top for 3 loaves for every 8 guests. So that's our fraction 3/8, which that's that fraction that keeps coming back over and over. We know when we divide that, we get 375 thousandths. And then table 3 was 10 guests, 4 loaves. So 4 loaves for every 10 guests. So that's our fraction 4/10, which is 0.4. So which table gets the most? Do the guests get the most? So in this one, we want to know which is the highest fraction or decimal. So it's table 3. Each guest gets almost half a loaf of bread. Did you guess correctly? So table 3 was the winner. Yay, table 3. Okay, Kalita can run 3 laps in 9 minutes. Sonia can run 2 laps in 7 minutes. Who is the fastest runner? So 3 laps in 9 minutes. So that means this one also reduces to 1/3. So we know she can do 0.33 laps per 1 minute. So in 1 minute, she doesn't make it quite all the way around a track. It's about 1/3 of the way. So how long would it take her to run 1 whole lap? So let's flip it around and do it the other way. So 9 minutes for 3 laps. If we divided that out, we would get 9 divided by 3 is 3. So it would be 3 minutes for every 1 lap. Okay, and then Sonia can run 2 laps in 7 minutes. If we divide that out, we get 0.29 laps per minute. I'm going to do that 2 divided by 7 here on the calculator. Please remember, you're not multiplying these numbers together. You're not adding them together. You're doing a division, 2 divided by 7. That 5 is going to round that up to a 9, so 0.29 laps per minute. So, and that's kind of hard to tell, like how far is 0.29, 29 hundredths of a lap. So let's flip it the other way, 7 minutes for every 2 laps. And if we do that, then we know 7 divided by 2, we know it takes her 3.5 minutes for every 1 lap. Okay, moving on. Peter and Caillou, I'm not sure how to say that, are making mini cakes for the school bake sale. Peter makes 5 cakes every 25 minutes. Caillou makes 3 mini cakes every 10 minutes. If they both continue to make mini cakes at the same rate for the same amount of time, which boy will make more cakes? So let's think about it here, like in terms like we did here. Is it going to make sense to talk about how many cakes in 1 minute, or how many minutes it takes to make 1 cake? So do we want to know like what portion of a cake for every minute, or what portion of minutes for every 1 cake? I think we want to look at how long it takes them to make 1 cake. Okay, so we're going to go minutes over cake. So let's see, the first one, we have 5 mini cakes in 25 minutes. So we have 25 minutes for every 5. I'm just going to put cakes. So that means he is doing 5 minutes for every 1 cake. He's making them pretty fast. All right, so then 10 minutes for 3 cakes. And when you divide that, we know that we have 3.3 minutes per 1 cake. So Caillou, however you say this, is making them faster. He will bake more cakes. Okay. On Monday, the school cafeteria sold 4 chocolate milks for every 10 white milks. On Tuesday, it was 1 chocolate milk for every 3. On which day did they sell more chocolate milks per number of white milks sold? So they give us the order, chocolate per white. So on Monday it was 4 chocolates for every 10, so 4 chocolate for every 10 white. And then I'm going to just kind of write this down here first. On Tuesday, it was 1 chocolate for every 3 white milks. Okay, so if we already have a unit right here. We have 1 chocolate for every 3. So can we reduce this? Can I divide both of these by 4 so that I can get a unit rate of 1 up here? So 4 divided by 4 is 1. So now we could compare because we have 1 chocolate on each. So 10 divided by 4 is 2.5. So for every 1 chocolate, 2.5 white were sold. Now I know you can't buy half of a container of milk, but we can compare the rate. So this would be 3 white milks versus the 2.5. So in that, you can compare it. So we know that they sold more on Tuesdays. No. No, so I read that wrong. Tuesday is not our answer. Looking at the question, it said, on which day did they sell more chocolate than white? So it's kind of hard to get our thinking around this. So for every one chocolate, there was 2.5 white sold. For every one chocolate, there was three white milks sold. So the smaller amount of whites gives you an amount where the chocolate would be more on that day. Okay, I'm sure you guys are kind of confused on this and how to kind of wrap your head around the fact that Monday is the most. But so let's think about it. If we have 4 chocolate for every 10 white, and then we have 1 chocolate for every 3 white, and we want to compare the amount of chocolate versus the amount of white, we need to look at it when the number of white milks were the same on each day. So if we set up some equivalent ratios with 30, because 10 times 3 gives us 30. So we know if 30 white milks are sold, we can then look at the number of chocolate. So we have a 10 times 3. So a 4 times 3, there would be 12. And this one would be a times 10 times 10. There would be 10 here. So Monday, this was Monday, this was Tuesday. On Monday, there's at a rate, if we had the number of white sold on any given day to be 30, the number of chocolate would be, on any given Monday, it would be 12, and on any given Tuesday, it would be 10. So Monday is our biggest. A tour bus drove 120 miles in 2 hours, and a school bus drove 180 miles in 3 hours. Which bus drove faster? So we're doing miles per hour is how we usually designate speed. So the tour bus was 120 miles in 2 hours. So if we divide that, they're at a rate of 60 miles per hour is how we abbreviate that. And then the school bus was 180 miles in 3 hours. So if you divide theirs, 180 divided by 3 is also 60 miles per hour. Neither, they were traveling the same speed, the same rate, at the same rate. Okay, and we'll see you on the next video.